This is the last section on simplification called Karnaugh Maps. And what Karnaugh Maps are is another way to simplify Boolean expression without having to use algebra. Now, it's a good crutch sometimes to use Karnaugh Maps when you don't want to have to do Boolean expressions and Boolean algebra to try to simplify. You should be able to do both ways though, because sometimes Karnaugh Maps won't work. It depends on how many variables you have. If you have more than 4, Boolean algebra may be the only way to go. So don't depend on Karnaugh Maps exclusively. Make sure you can do it a Boolean algebra too. And to be able to do Karnaugh Maps, you have to have it in the sum of products format before they can be used. Let me remind you what sum of products was. Remember, sum of products I talked about a while back, where it was something ANDed together, ORed with something else ANDed together, ORed with something else ANDed together. It has to be this or this or this or this. It can't be parentheses and things like that. In other words, you couldn't have CD ANDed with B, A, or D, C. Couldn't have that. That's not sum of products. That's something different. That's actually nothing at all. You couldn't have that though. But you could convert this over to sum of products by multiplying through. But you have to make sure they're in this sum of products format before you can actually put them in a Karnaugh map. So let's look at what a Karnaugh map looks like. Now this is a 2-variable Karnaugh map, and you'll see that the variables I used are just A and B, but it could have been, you know, X, Y, or QP, or whatever. It doesn't matter what the variables are called, as long as you have the lines in the right places. So in this case it's not, and then regular, and then not, and then the regular expression, the regular variable. So you have to have the nots on the inside. Now sometimes you'll see these laid out, and I don't particularly like it this way, but you'll see it listed as this, and your book sometimes does this too. A lot of the textbooks love to use this layout for it. So let me lay it out here for you. And like I said, I don't particularly care for it, but they'll lay it out like that, which this is the A, 0 meaning not, and A just the regular A, and then you got B with the 0 being not, and then just regular B. I'd rather just go ahead and write the variables there so I know what they are, but you will see this layout in a lot of textbooks or technical documents, things like that. But all it means is this is A not, since it's on the A part, and this is A, and this is B not, and this is B. So if you ever see one of these, that's all it means is it's just laid out like that. I don't know why they do it that way. It's just what some people do. Okay, so let's do an example. Let's map one. And we've got this expression AB or AB not. Now you could probably see, yeah, Boolean algebra, I could pull out the A and the B and the B not. Well, you know, one, you got anything ordered with its opposite is just a 1, and then that cancels out, you're left with A. That's doing Boolean algebra. But for a Karnaugh map, we're going to play Battleship. And if you ever play Battleship, you remember you got letters on one side and numbers on the other, and you say like B5 and D4 or whatever, and you put your little marker there. Well, we're going to do really similar right here. The first variable term, the first set of variables is AB. So we're going to find A, which is right here, and we're going to go down to where B and A intersect each other. At that box right there, we're going to put a 1. So wherever A and B intersect, we're going to put a 1 in that box. Okay? And then the next set of variables, we're going to have A, B naught. So there's A, there's B naught, and wherever A and B naught intersect, we're going to put a 1 right there. Okay, so AB right here, and A, B naught is right here. That's mapping it. Now we need to do what's called grouping. And for Karnaugh maps, you have groups of either a 1, 2, 4, not 6s, 8, and you get really big ones, you could have a 16, which pretty much takes up the whole chart. But it's just like in binary, 1, 2, 4, 8, 16. So that's the only grouping numbers you can have. They can only go up and down and side to side. No diagonals. You cannot go diagonally. So if we look at this group, we've got a group right here of 2. So basically we're going to be able to simplify this. Now the easiest way I found to kind of figure these out is we're going to look up on this group and we're going to look side to side on this group. So if you look up in this group, we have a single letter that we're showing, and that is A. So write down A. If you look to the side here, we've got a B naught and we've got a B. Well, you can kind of think of B naught and B canceling each other out, so we're not going to write them down. So A was by itself, nothing canceled it out, and B naught and B cancel each other out, so we don't write it down, so we're left with A. A is our final variable. So AB or AB naught equals A. And if you're unsure how I did that, rewind it, watch it again. We'll do some more variables if you want more examples. If you want to keep going, I'll leave that up to you. Now this one, a little bit bigger. Still two variable, A and B. We didn't go to C's or anything yet. And A naught A, B naught B, same thing. So first thing we're going to do is map AB. So we've got A, we've got B. They intersect in that box right there. Next one is A naught B. There's A naught. There's B. So we're going to put a high there. And the last one is A naught B naught. So we've got A naught there, B naught there. They intersect in that box right there. And remember, groups of 1, 2s, 4s, 8s, 16. So we've got a group of 2 right here. Always try to get the biggest groups you can. Now it looks like we only have a group of 1, but guess what we can do with these things? We can reuse, we can overlap if we need to. Now if it didn't help you get a bigger group, don't overlap them just to be overlapping. But if it helps you get a bigger group, then by all means, go for it. Overlap them. So let's do this up-down group right here. You look up, we've got A naught. And if you look to the side, it takes up both of these rows. So we've got a B naught and a B. They cancel each other out. So group right up and down is A naught. And then we've got another group that goes side to side. So if you look up, we've got A naught and A. Well, those cancel each other out. So we don't write that down. To the side, we're only in that one row. Got B. So AB or A naught B or A naught B naught equals A naught or B. And I will get you to write out the simplified diagram for these. So the only one you have to write is this one. You can do it this way just to be, there's our OR gate. And if you want to be there, and I'll let you cheat, you can just do A naught and that's fine. You can just lay it out like that. You don't have to do the inverter. If you want to do the inverter, that's fine, but you don't have to. Okay, let's go to the next one. Okay, this one is a 3 variable, and you'll notice that we've added AB and then we've got a C now. What we do with these, you got AB, 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 and you got the C on the side. And you might see it the other way where you've got AB, AB, AB on the here side, and you've got 2 C's up here. I've seen it both ways. This is just a little easier to see for me. I personally like this way better. And then you'll see that you have 3 knots in a row, and you've got the last one inverted. So you've got not, 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 and then not, if you kind of remember it that way. So the very first 3 and then the last one. And then the C is just like your A and the B variable last time. Your inverted one is the first, and you've just got the regular C there. So this is a 3 variable one. Kind of get used to being able to draw these out. And we'll also do a 4 variable, and then we won't go any higher than that. Remember, AB's, C's on the side, not, not, and then a not on the side there. So let's look at an example of how to map these. So for the 3 variable ones, it's just like we did the other one. We just figure out where these intersect at and draw 1. So the very first one is A, B, C. Well, here's AB, and here's C. So A, B, and C intersect in that box right there. A, B naught, C. A, B naught, C intersect right here. And then A, B, C naught intersects right here. And again, we've got 2 groupings here. We've got a grouping here. And let me get a different color. That way it'll stand out a little bit better. Let's do blue. And then we've got one here. So let's do the blue one first, since that's what my pen is. So we look up, and we've got A, B, and we've got an A and a B naught. Well, the B and the B naught, think of it this way, they cancel each other out, so what are we left with? We've got A. So we're going to draw A, and then you look to the side, and what do we have to the side over here? You just got a C. So you look up, it takes both of these columns, right? AB and AB naught. The B and B naught cancel each other out, so you write an A. And we're only in this row, so we're only in the C row, so you write the C. The next group, put an OR because it's another group. And let's go back to red. This one, if you look straight up, we have an A and a B. We don't have anything else. Nothing cancels each other out. So we're left with AB. And if you look over to this side, we've got a C naught and a C. Well, C naught and C cancel each other out, so we don't write it up here. So that's our final answer right there. So the blue one, again, A, B naught, and B cancel each other out. C on the side. And this one, you look up and you see AB, and C naught and C cancel each other out, so you just got the AB. So let's do another one. Okay, in this one we've got A naught B, C, and if you want to, you can pause it and work it out yourself if you want. And we've got A B naught C, and we've got A naught B naught C. Now this one's a little trickier because this one's going to use something they call a wraparound grouping. This grouping is pretty obvious. We've got a group of two there. But what we can do is think about wrapping this image around a can where it's round, where this side touches this side. As long as they're on the sides and we're doing it, you know, side to side or up and down, they can actually touch each other. So let's do green. So this one will actually group with this one. So we've got the green group. Let's do that one first. If you look up, it's taken this column and this column. You've got an A naught, B naught, and an A, B naught. Well, the A and the A naught cancel each other out, so you're left with B naught. And the green one, so we're going to look over here. We've got a C. That's all we got for that group, so do an OR. And we do the red one. Red one, you look straight up here, and you got an A naught, B naught, and an A naught B. Well, you got a B naught and a B, so that's on the left is A naught. And you look to the side again, you're left with C. So the big difference here is that wraparound. You can do a wraparound as long as they're on the edges. Like I could have wrapped around from this one to this one if I'd wanted to. So wraparounds help you get bigger groups. If we had it by itself, it wouldn't have been as simple as we could have gotten it. So biggest groups you can possibly get. And you notice I reused that one. We overlapped it. Let's do another one. So we've got A naught B, and we've got C, and we've got A B C, and we've got A B naught C naught. Right? A naught B C, A B C, and A B naught C naught. So we've got this group of two. It's pretty straightforward. We can see that one pretty good. And if you look, can we do anything with that? Can we do anything with this one? Well, if we could do diagonals, we could group it there, but we can't. There's nothing up and down. There's nothing on this side. There's nothing here. There's nothing over here, so we can't do end around, the wraparound. So it's all by itself. That's all we can do. So if you look up, we've got A, B naught, and then look at the side, we've got C naught. And you'll notice that just recreated the exact same thing because we didn't group it with anything. We didn't simplify it. And that's going to be, that group is ORed with the next group, which is the red one. And that looks up here, and we've got A naught and an A cancel each other out, so we're left with B. And look over here, we've got C. So it's A, B naught, C naught, or B, C. So why don't you pause the video, try some of these out on your own, see how you do. And the first one is just a 2 variable one, and the next two, there's 2 separate ones there. This one, you got 1, 2, and 3. Those are not the same ones. So do those and pause the video and come back when you're ready and check your answers. Okay, here's your answers, and I didn't do all the Karnaugh maps, but if you do want to see the Karnaugh maps, just let me know and I'll send them to you. But if you do get something wrong, try to go back and recalculate them again. Now that you know the answers, maybe you can figure out where you went wrong. So I'll move on now. This is a 4 variable, and the 4 variable one is very similar to the 3 variable ones, except now we've got the A naught, B naught, A naught, B, A, B naught. Now we've added this D variable to the side, and you'll notice that the inversions is the first 3 and the last one, just like the top line is. So it's the first 3, the last one with 4 variables. And this is the biggest ones we'll go to. We won't go any bigger than this. So let's look at an example. Okay, let's map this. And this one kind of gets some crazy maps sometimes. We'll figure them out as we go along. I'll try to give you as many different examples as I possibly can without giving you every possible example, but I'll give you a good sampling of them. So the first one's AB and CD. So we got a 1 right there. Or A naught B, CD, A naught B, CD. Then we got AB, C naught D. It's real easy to get messed up on these things. And an A naught B, C naught D. Right there. Now we could do groups of 2. We could get a group of 2 there, a group of 2 there. We could do a group of 2 there and a group of 2 there. But all 4 of them are together. So why not remember we can do 1s, 2s, 4s, and 8s. Why not go ahead and do a group of 4? Biggest groups you can possibly group together. They're all next to each other. There's no diagonals, no gaps between them, so we can get all 4 of them. So if you look up, the A naught and the A cancel each other out, so we're left with B. And if we look to the side, we've got a C naught and a C cancel each other out. All we're left with is D. And you notice they're together. There's not an OR because they're one single group. The only time you OR is if we had another group. So we've got up is B, to the side is D. The answer is BD. So let's look at another example. Let's do AB, C, D naught, and AB, C naught, D naught, A, B naught, C, D naught, and A naught, B naught, C, D naught. Now this one's a little trickier. We could do a group of 2 there, but that's not the best option we have. If you look, this would be, if we overlap these, we've still got this one by itself and we've still got this one by itself. So we would need to do this one with something and this one with something. So you end up being a redundant grouping right here. You don't need it. And the best way to do this one is, remember, we can do side to sides, but remember I said you could also do top to bottom. So in this case, we could do from there to there. We can do those groupings. And we can do, let's see, green. We can do a grouping here and over here. So you got the red group and the green group. And if I'd done this grouping, right here at the bottom 2, it really wouldn't have been as nice. It wouldn't have been as good to have because it would have been an extra grouping I didn't need. And just remember, if you get them up and down, if you did do an extra grouping there, you can kind of look at it and go, oh wait, I don't need that extra. I've already used them both and I don't have to group them, so I'm not going to. So let's look at the green one. We got straight up on these 2. And we've got a B and a B naught, an A naught and an A cancel each other out, and we're left with B naught. And if we look to the side of this one, we've got C, D naught. So that's one group. And then we're going to do the next group. So let's go back to red. And the red one is actually just in this column right here. So we've got AB, nothing cancels out. And it's these 2 rows. So you've got C naught and C cancel each other out, so you're left with a D naught. So let's look at the next one. So do you notice anything strange about this one? You see that it is 4 variables, A, B's, and I've got some C's and I've got some D's. So we are using 4 variables, but I didn't give you all 4 variables for this one right here. I only gave you 3. So let's figure out how to map this one. The first thing is we've got to find AB. So there's AB in this one right here. And we need to find the D's. Well, ABD is right there. There's a D. And right here, there's a D. You see that? There's a D here and a D here. So ABD is actually going to be both of those because we didn't specify which C we were using. So we're going to use both of them. So we're just going to do all the D's. For this one, it's A naught B. There's A naught B. And D, A naught B, and there's a D, and there's a D. Right? And then C naught D, well, in that one, I didn't give you any A's or B's at all, so it's just going to be all the C naught D's. So it's everything in this column. There I've already got one, there I've already got one, and there. It's all the C naught D's all the way across. It'll be all 4 of them because I didn't specify an A or a B or an A naught or a B naught. It's going to be all of them. And the last one's going to be an A naught, which is both of these right there and there, and the C naught D. Well, there's the A naught C naught D, and there's the A naught C naught D. So I've already got ones there, but that's okay. We don't know that when we're simplifying them. Now let's get groupings. Well, we've got the center group of 4 here, again, that we can use. And we could do a wraparound with these 2 by themselves, but that's not the biggest group we could get. We can actually get a group of, if you look at it, probably figure it out before I get my color in, we can actually get a group of 4. They're all next to each other, and we can do groups of 4. Now if you look up, it's all 4 of these upper ones, and you see we've got A naughts and A naught and A and a B and a B naught and a B and a B naught. So all this cancels each other out. If you look to the side, we're left with C naught D. And then if you do the red one, it's OR because we're doing a different group. See red. The red one is this one and this one. So we've got A naught and A cancel each other out, and we're left with B. And we've got this way and this way. We've got a C and a C naught cancel each other out, so we're left with a D. So C naught D or BD. And yeah, we could, looking at this, we pull D out, but it really wouldn't simplify it any more than what it already is. By the time you get done, if you do the Karnaugh map correctly, you really can't simplify them anymore. They're as simple as they're ever going to get. Okay, let's do another one. So we've got A naught, B naught, C naught, D naught, which is right here. We've got A, B naught, C naught, D. We've got A, B, C, D naught. And you've got A, B naught, C, D naught, which is right here. Wow, it doesn't look like we can do anything, really. We can do up and down, right? We could do the wraparound. Or we could do side to side. We can do side to side and do wraparound from side to side. But there's a trick for these Karnaugh maps. Since they go side to side and they also go up and down, we can do this weird thing where we can kind of group all the corners together as one big group. So we've got a group of 4 doing all 4 corners. Okay? So if you look at it, you can loop it up and down, up and down. You can also go side to side, side to side. That means you can do all 4 corners. So anytime you see all 4 corners, go ahead and group them as a group of 4. So if we look up, we've got this column, and we've got, it looks like an A naught and an A cancel each other out, so we're left with B naught. And since it's the same group, we're not going to OR it. We're going to go to the side. And we've got C naught and C cancel each other out, so we're left with a D naught. That's our only group there, so there is no OR. We're done. That's it. That's all there is to it. So corners are great help if you got them. Now pause this, try these out on your own, see how you do. I'll come back and show you the answers to them when you're ready. Okay, here's the answers, and You can see that Karnaugh Maps with these equations, it seems like they're going to be really big equations, but by the time they get simplified, they're very actually small equations. They go down to something fairly small. And I would personally not want to do Boolean algebra on any of these. It's much easier to do Karnaugh Maps on them. It would take quite a while to do a Boolean algebra on these. So if you need to look through these some more, pause it. If not, just keep going. So this is the last section on simplification, and you're done with this section, and you can go ahead and work on other things.